20 plus 6 2 is 120, 240, 50, 80. Oh. Yeah, there's no one here.
Wow.
So when there's no one here, I get to make up problems and do them by myself.
Fun. Sure, that's all kind of fun.
Oh, it's wonderful. I mean, it's not terrible out there.
Yeah. Well, we got some actual problems.
Yeah, some real ones.
Because yes, they have like those conceptual analysis help things, but I don't feel like going through 20 steps to try to figure out how to do it.
Yeah. Are they all collisions? What do they have in them?
This one's the conservation of momentum.
Okay. Yeah.
This one is conservation. The next one that I have is elastic collision.
Okay.
So this one is that you got a bullet mass of 20 grams, velocity of 100 meters per second, colliding with a wooden block that's attached to an immovable wall. That's initially initially at rest. And what's the maximum compression of the spring?
Okay. So it's still a collision.
And it's saying that you may assume that the spring is massless and collision between the bullet and the wooden block is completely inelastic.
Completely inelastic. Okay.
Yeah.
So they stick together and become elastic.
I'm guessing.
Yeah. Okay. So yeah, bullet, block, a spring, and a ball. Do you have a spring constant?
Yeah, 800 newtons per meter.
And the mass, I'm assuming.
The mass of that was 2 kilograms, 20 grams for the bullet. And the bullet has an initial velocity of 100 meters per second.
Kilograms. Did you say 120?
100. Just 100.
Just 100, okay. 20 was the grams.
Yeah. Then it wants to know what's the maximum compression of the spring.
Okay.
How do you know? This?
We didn't do the force equals change of momentum over time, did we? Okay. So, where would you start?
I have no clue. That's all I gave you.
No idea. It's a big guess. Given that we're going to be using what is this thing? It's energy is going to be constant. Right, conservation of momentum. So, given that we're going to be using that, what do you think would probably be a good thing to use?
My biggest thing is I don't even know what formulas there are to choose from to use.
Mm-hmm.
Which was where I was going, okay, how the hell do you do this thing?
Mm-hmm.
Because I know all kinds of formulas if it was just mass and velocity.
Mm-hmm.
Throwing the K in there just throws another spin on it. That's like, okay, what the heck does that?
So you know the collision is inelastic. What
Mhm.
does that tell you?
That it just keeps going velocity that way.
Yes.
That it doesn't bounce off.
Yeah, that they join together and become one object. We also need to use conservation of energy.
Mm-hmm.
So energy is 0.
Mm-hmm.
And actually, I just use that because you have kinetic and potential,
Mm-hmm.
right? So originally, if you make your system everything, what do you have?
What do you mean by that?
Okay, if you have how do I say this better? If this is your system,
Mm-hmm.
what energies do you have initially?
The mass and the velocity of the bullet, and the mass and the spring constant of the spring.
Yeah, what energies? Like kinetic energy, potential energy.
Both.
Both. Is the
Is
spring
it?
extended or compressed?
Say.
I'm
guessing.
assuming it's
I'm guessing extended.
if it's just sitting on
Or
the
just
wall
regular.
and there's no forces acting on it before the bullet hits the block.
Yeah, it's just sitting there. It's not extended or compressed.
Yeah. So at the beginning, you only have the kinetic energy of the bullet.
Mm-hmm.
So you have 0.02 kilograms. Velocity is 100. And that works. And then,
Oh, that's the MV squared over 2.
yeah, at the end, the bullets hit the block, it's compressed the maximum amount.
Mm-hmm.
What do you have at that point?
Do you have potential at that point then? And kinetic? Yes. No?
I'd assume that what happens is the bullet hits the block, and then the block at first compresses, and then it goes back and forth like this. You know how the spring will oscillate.
Mm-hmm. So
when it's compressed all the way, right before it changes directions and goes to the left,
Mm-hmm.
what would be the the velocity of the block?
Is it just simply the 100 meters per second or no?
Let's see.
So it starts at
I definitely gave you that steered you around there. You shouldn't make the whole thing your system, or you should, but let me think about this for a second. then we'll see if this works, and then if I did the collision part wrong, because we ignored the collision part.
Mm.
We should have done that first. But we'll just see if this gets you the right thing. You'd have only spring energy at the end. So that's 1/2 kx squared. And solving for x should give you some number.
So
There.
So
I think-
number on the left, divide by 1/2.
Yeah. We'll put this.
So 0.25, would that sound reasonable? 0.25 meters?
Yeah, that sounds right.
Okay, let's see if that's right. Nope.
Nope. Okay. So this is what we should have done first, is figured out the velocity after they collide, the initial velocity. For an inelastic collision, they stick together like one object and move together at the end, so it's really easy to find the velocity afterwards. You have the bullet, you have the box. And so you just, like 2 kilograms. 0.02 kilograms. So you can solve for, use conservation of momentum. M1v1 equals M2v2.
So I got V2 being like 9.9 meters per second.
Okay.
Does that sound reasonable?
Let's see. 0.2 times 100
Here,
would be
let's see the
about
calculation.
2. You would have 2 would be M1v1. And then 2 divide that
wait,
by
yeah.
2.02.
Yeah, just a sec. I did 0.2 times 100. There we go. Okay, 0.99 meters per second.
Whatever. Okay.
And it's got a really weird repeating pattern.
Yeah?
0.90099009900.
Huh. Well, that sounds familiar. Okay. And then do your conservation of energy after that.
Which is what now?
Which is the kinetic plus potential before is equal to kinetic plus potential after.
I'm saying, what was the formula for that?
So what energy do you have before?
Before was just kinetic.
Mm-hmm.
And was after just potential, or was it both?
It was just potential.
Which was the 1/2 K?
Yeah. Because initially the block has the velocity that it's gotten from the collision, right? And it's
So where does this new velocity come into that equation?
the V in that equation is V2.
Oh, okay.
And the mass is the combined mass of the bullet and the block.
Okay. Now I'm getting a ridiculously small number.
That, I mean, could be correct.
Like
0.99 squared.
I've got 0.002.
That might be right.
Like,
It would be meters.
okay.
So it's like 2 centimeters.
No, that's not right either.
Okay. In that case,
Here, make sure it probably, so, make sure I did
MV
it right.
squared over K.
Did velocity squared
Okay.
times it by 2.02,
Mhm.
and then times that by 0.5, and then divided by 400 since the kinetic is 8.
That should be right. Take the square root.
No, I did not do that right. Hey, that number's actually reasonable.
Mm.
A little bit closer to 1. Yeah, that's the right number. The right one.
Good.
I just gotta do stupid follow-ups afterwards.
Oh.
Okay, that section.
Okay.
Now we got this one. This one's elastic collision.
Okay.
So it says block of mass 1, 3.5 kilograms, moves with a velocity of 6.3 on a frictionless surface, collides with another block, which is initially stationary. Blocks stick together and encounter a rough surface. The blocks eventually come to a stop after distance. What is the coefficient of friction?
Okay. So how would you start?
Is this one literally just like that screen one we just did, pretty much?
Yeah. Very much.
So it would just be find out the velocity and then use that in the, wow.
Yeah, find the velocity. Use that for the change in energy is going to be equal to the work of friction.
Okay. Now you find the velocity blocks when they crunch together.
Do they stick together?
Yeah.
Okay, so
Yeah.
inelastic collision, it's literally exactly like.
I know it's the total mass times something velocity. Right? Or is that, or am I
I would
thinking?
just use conservation of momentum, just easy. Very boring.
I have a mass 1, mass velocity 1, mass 2, velocity 2 over total mass. Right?
F1v1 over total mass. Yeah,
Oh.
that's not conservation of momentum, but you just round off, I think, the velocity center mass. But that makes sense because they fit together, so
Okay.
it should end up being. Yeah, that makes perfect sense. Okay.
I don't know where I got that from. I just remember that
I
formula
think-
coming up many, many times in the homework.
Yeah, that's how Professor Blodowski explains collisions in terms of the center of mass,
Yeah.
which is a whole lot easier than the professor I had's version, where he actually had to use conservation of kinetic energy.
Okay, so we got 4.24 for that.
Okay.
So we've been moving slightly slower than it was originally. Sounds right.
Yeah.
Okay, so now it's just 1/2 mv squared equals. Is it just going to be 1/2 kinetic friction times the velocity?
What?
We're trying to find the kinetic friction
The
coefficient.
coefficient?
So it's going to be 1/2 mass times velocity squared on one side. But what's the other side?
Okay. Do you know V1? Do you know the distance it takes to come to a stop?
Yeah, 1.85 meters.
Okay. So, the acceleration, deceleration, that, alright, that would give you x equals x1 plus v mod x t plus 1/2 x t squared. I would use this formula along with
How the heck are we finding the t?
some of the forces.
How the heck are we finding some of the t?
Yeah, I did that wrong. That's not what I meant. You need that formula and v equals v1 v1 plus 1/2 a naught x t. They're not 1/2, just ax t.
I don't think we know any of the accelerations either.
No, you have two equations, two unknowns, right? You don't know
have
t.
two unknowns.
Yeah, but you have two equations.
So how would we figure
For a system of equations, in order to solve for two variables, you need two equations, right? So,
if that's in calculus 1, that's a foreign concept.
that's in calculus 1, right? Because if you have 3x equals y plus 5 and like y equals 7x plus 8, you can solve for x and y, right? If you were given these two equations,
Okay, yeah.
right? It's
somewhat
one of those like, but then if there was a z in this one, you couldn't solve it unless you had one more equation.
Yeah.
Right? So it's that concept. If you have two unknowns, you need two equations. You have acceleration and time are unknowns, so this equation is enough. You take the derivative of this equation to get this equation. Which I think he gives you both in your equation sheet, or he expects you to take the derivative.
So how do we use those two then to figure out this?
Well, after this distance, the velocity is 0. So
would that be x? X is
yeah. When x is 0, velocity is v1. When x is 1.85, the velocity is 0.
Okay.
So you have 2 points that you can go off of. I think there's a way that at some point they would put one equation into the other.
So are we saying so we can solve B for acceleration or time?
Yeah, solve for A or T and plug it into this. So like you could say acceleration is going to be v1 over t. Plug it in here, you would get v1t instead of acceleration times t squared.
Okay.
And then at the end, you would use some of the forces is equal to ma. You have A and the force.
X1 would be 0, right?
X1 is 0, yeah.
Okay. Plus, V naught X would be the
Velocity.
the velocity that we
you
found.
Yeah.
Okay. Plus 1
Although, actually the substitution doesn't make sense, but it works. You'll find T.
Why wouldn't it work?
Well, you would find T. It would make more sense to do to V1 over A, then you could find A. Math might be easier to find T and then plug it back in.
Yeah, that's what I'm looking at, is that plugging in the substitution for A knocks out A and then makes it so that each one of them is just T and T instead of T squared.
Yeah, so that's much easier.
So it makes it so that you're actually just solving basically a linear versus a quadratic.
Yeah.
Quadratics are a bitch.
Mm-hmm. Quadratics you can just grab.
So it should be 1.5 equal. What's B1 again?
B1 is the same as B of X. I should have written them the same, but
Oh,
I
okay.
didn't, yeah.
So you're basically just going to have 2 times. What? So if V naught was 4.24, it is 6.636 T. So would coefficient of friction, so I got for that, so T I've got is equal to like 0.29. Does that make sense?
That sounds like a fine number.
Okay. And how do we use that?
You need acceleration, because then you can plug it in to find force.
Okay. Lovely.
The force that caused that acceleration, which is friction.
Yep. Oh. So would an acceleration of 14.58 sound reasonable?
Let's see, 14.58. What is that times? What's that times T?
What's that times T?
Multiply that by 0.29. You get your velocity.
0.42279. Right.
Is that your velocity?
Oh, never mind. I did times 0.029.
Oh.
That doesn't exactly work as well.
You can check by plugging in.
4.22. I think that was our velocity.
Yeah. If you plug the time you got and the acceleration you got into the x equals x naught plus v naught xt, that equation, and get the distance you started with, then you have correct numbers.
Okay.
So it's just a check it for the equation.
And then x1 we said was 0, right?
x1 is the velocity you got when you started. It was the 4.
x1 not v naught.
V naught and oh wait, sorry. Okay. Yeah. 0.
Okay.
This is also
I'm still getting an acceleration of like 14.57.
Yeah.
Plugging T back in, it's like,
Yeah, if that's the acceleration you got, that's good. I meant plug the acceleration and the time back in and see if you get X. But if you're still getting the same thing, then it should be right. Yeah.
So plug this times T squared.
Okay. And it's probably growing right now. Okay. I'm gonna go find it.
Yeah.
Yeah.
Yeah, when I plug the acceleration back into that, I get the 1.85.
So you have all the right numbers. Now just use them to find.
So now it's just simply the total mass times that acceleration.
Yeah, total mass times that acceleration is going to give you the force. Does it ask the force or the coefficient?
Coefficient.
So, what's the force of friction equal to?
That's a good question. Which I have no clue at the moment.
Okay.
Well, I know the force of friction, it says it's 75.811 meters.
Okay, that's
per
good.
minute or whatever.
So what would, I'll just tell you what the formula for friction is, because you just look it up on the formula sheet otherwise, which is UK times the force, right? Which is UK mg.
So now we set this number equal to that?
Yeah.
Okay.
So it's divided by mg.
So divide mass times 9.8.
Yeah.
So 1.488.
That sounds about right. Actually, that's so really that's high.
Yeah, that's wrong.
That's wrong. Yeah, that's too high.
Now the fun process of where did we go wrong?
Yeah, the acceleration should be less than 9. Wait,
It was like 14 something.
14. Yeah, that's too big.
Okay.
Sorry, I should have thought about this last equation and realized that was way too big. Is that the right distance?
Yeah, it says it's 1.85. That's given to us.
Okay, and it says it stops completely.
And it says the blocks eventually come to a stop after traveling that distance.
Okay. Did you get the correct velocity?
I think so. How did we find the velocity again?
V2 equals m1 v1 m1 plus m2 of velocity.
So m1 v1
Yeah, I'm just gonna call this v1.
times 6.
Call this v1.
Yeah, 4.240.
Okay, so it shouldn't.
Because the initial velocity,
Yeah.
the first one was 6.3.
Okay. That makes sense. That's a good number.
Okay.
Equal to A over G. UK should really be less than 1. That could give you be 2 plus 1/2 b squared t. Or, no, not b squared t, just bt. So that would give you 1.5 bt.
So x equals
So
1.5.
t equals x over 1.5 bt. What is that?
Let's see.
Yeah. 2x over 3 bt. Is it right? I don't know all of the markers. I always do this.
Yeah, 0.291.
2 and 1, that's the same number of seconds.
Yeah, we're getting the same time.
Same time.
I'll just solve it for acceleration, maybe.
It should just be that velocity divided by that time, which is greater than it should be about 1, 2. Yeah, 14 doesn't sound super far off for that.
14.579. We're getting the same
Something's really off here.
Yeah, we're getting the same acceleration, same time. But what's wrong?
Yeah, the acceleration's still way too high. Mass times acceleration, UK and G. Mass completely cancels out of that equation. It's just the acceleration divided by gravity. Mass isn't involved in any of this. It was only involved in calculating V naught. We haven't misread any of the numbers in the problem, right?
Now we got 3.5 kilograms and 6.3 meters per second. And then 1.5 kilograms.
Okay.
Or 1.7 kilograms.
I have no idea what's wrong. Because there really should. Okay. Let me try something else. This is technically over, but this is annoying now. This password was something. I don't remember how many there were. What were the other ones? Oh, there you go.
Why, what are you doing?
I'm looking this up. Which problem is this?
Is Unit 12 the last problem, was it?
Is this homework?
Yeah, it's on the home
It's the last problem.
Actually, no, it's that one you've got up right now.
It's this one.
Yeah.
So mass is 3.m1, m2.
Wait.
Are these the numbers you have?
Yeah. And we got like 1.4.
Completely different answers. Let me look. It's
How did we get to 0.49?
help. Which of the following choices is a quantity that is conserved in the collision? Yeah. Okay, so first, we do that. Which of the following concepts can be used? C and D. Okay. Okay. So initial. Yeah, that's what we used. Yes, that's good. After the collision, kinetic energy. Why do we use kinetic energy here? Okay. Oh, work. You could use that too.
What?
Use, ouch. Okay. A better way to solve this problem.
So where does the way we're supposed to do it differ from what we're trying to do?
So you found the velocity. Technically it should get the same answer, so we were probably doing something wrong. After the collision.
Delta P squared.
Whatever that is. It's, I don't know the best way to describe. Yeah, change in kinetic energy, so it goes from 1/2 mv squared to 0 is going to be equal to the work, which is force times distance, which is, we basically tried to do it the really hard way.
And what's the really easy way?
Okay. Just equate those two.
So now we're doing mg. So 1/2 mv squared equals mg uk d.
Yeah.
Okay.
Yeah. So I've got to go, but hopefully that's helpful. Yeah.
That's total mass, right?
That is the total mass, yeah.
Okay. How did we find the force again? Friction?
Force of friction. Do you remember the formula for that?
Not a clue.
It's the normal force times the coefficient.
All force times the coefficient.
Yeah,
Times what coefficient?
the coefficient of friction.
Coefficient of friction is what we're trying to find.
Yes.
So
That, okay, so the work done by friction is the force of friction times the distance. The work is equal to the change in kinetic energy.
Okay. The distance. And then the force you said is mu k times what?
Mu k times the normal force, which is mg.
Times the total mass times gravity.
Got everything you need?